Okay. You were probably given a conversion table at some place in this thing up here, above the your conversion tables. And the I'm not seeing it, but there's oh, I'm sorry, we're just doing US units. Okay, so you start with the given quantity, 2,000 inches, and you go down here and you write inch and feet, because you can go from inches to feet. So there are 12 inches in 1 foot. So the inches cancel, and you divide here. Now, did your instructor emphasize significant figures or scientific notation or anything like that?
No. Just doing the cross multiplying and
All right, so this is 167 feet. Nothing to that. All right, so we'll go a little faster. I was distracted by thinking you were doing something else here, and you're not. So 4 is 2,000 feet in inches. So you start with the quantity that you're given, 2,000 feet times, and then you put feet on the bottom, inches on the top. So it's still 12 inches in 1 foot. Those cancel, so you multiply and you get 24,000 inches. So if you know the conversion, it's pretty straightforward here. All right. So this is where it gets a little bit tougher. Let me scroll down here. So we have 2,000 inches squared, and then we know that there is 12 inches in 1 foot, but we want inches squared. So we square the bottom and we square the top. Okay, so what that looks like, and we'll just do it for this first one here, is you end up writing 1 foot squared, 144 inches squared, and then you see the squareds cancel.
Yeah.
Okay, but you have to square your units. It's a common thing that's forgotten when you do this.
Yeah.
So that's 13.9 feet squared. And
That's the end of that one, right?
yeah, now these in this Google Doc got formatted really poorly. I don't know which one's 8. I can't tell.
8's going to be the 2,000 feet squared equals question mark inches cubed.
Inches squared, right?
Squared is squared.
Yeah. Okay. All right. This thing on my side looks real bad. Okay. Yeah. So we got that there. That's number 8. It's the same idea. 2,000 feet squared times you put your feet on the bottom, your inches on the top. Again, there's 12 inches in 1 foot, and then you square both of them. You don't have to write out this next line because the feet's ending up canceling. So it ends up being 2,000 times 144, which is 288,000 inches squared. So they really emphasize the units here. So pay a lot of attention here to make sure you've got that down.
All right.
Okay, on to 10.
Yeah.
All right, so 2,000 inches cubed into feet cubed. Okay, this is again very much similar. So you write 2,000 inches cubed times you have 12 inches and 1 foot, and then you cube the bottom, cube the top. Okay, so this becomes like, this is what you really care about. Those cancel and that cancels. So you end up getting 2,000 divided by 12 cubed. That's this part, and then it becomes feet cubed. Okay, so a lot of cancellations are 2,000 divided by 12 cubed, and that's 1.16 feet cubed, or cubic feet. You might see that.
Those 1.16 feet.
Cubed.
Let me out the 1.16.
Is there a question there? I'm sorry, I'm not sure I follow.
No, it's nothing.
Okay.
I was cutting it out. On the number, we're going to be doing number 11 and 12.
Okay, I see them right here. All right, so there's 11. Grab that. All right. So we got 1,000 inches cubed. Okay. And now we cannot go. Here's what we can't do. Well, we can do. So there's inches to feet, and then there's feet to yards. Okay. So this is kind of the best way to do it. So it's 12 inches in 1 foot, and then there are 3 feet in 1 yard. Do you follow that?
Yeah, I do.
Okay, but we need cubes. So we have to cube this. So we have to cube that. And then we need to cube that. And then we need to cube that.
All right.
The reason is because we're trying to get rid of that. So that gets rid of that. That gets rid of that. So these exponents really only apply to the numbers. So in your calculator there, it's 1,000 divided by 12 cubed. And then you have 1 cubed over 3 cubed here. So you just have to make sure you get it into your calculator. The way I like to do it is I like to go 1,000 / 12 cubed / 3 cubed, like that. And if you got a calculator handy, go ahead and grab that and let me know what you come up with.
Oh,
We got 1,000 over 12 cubed over 3 cubed. And I get 0.0214 yards cubed.
214 or 212?
I get 214. 1,000 over 12 cubed or 3 cubed. Yeah. Okay. So you might be asking, well, why Matthew did you write to 3 decimal places? I don't know. Maybe this one's 4 significant figures. That's why I asked from the beginning. I really don't know how many you're supposed to give here. They don't say. So you may want to check with your teacher to ask, like, hey, we just did significant figures. How important is that? Is that here?
All right.
I can't tell you that.
Well, for now, on to number 12.
On to number 12. So start out with 2,000 feet cubed times foot to inches. So this one's nice because there's a direct conversion. So there's 12 inches in 1 foot. So you cube both of them. And you end up getting, this ends up, because that cancels with all of that, this ends up being 2,000 times 12 cubed inches cubed. So you just got to get that number there, 2,000 times 12 cubed. And that becomes 3, 4, 5, 6, 1, 2, 3. So it's 3,456,000 inches cubed. It's a lot of inches cubed.
All right.
Okay, now we're back to the evens, so like 14.
Yeah, the rest of this will just be evens.
Well, interestingly, I can't figure out where 14 is. There it is. You saw what I'm seeing. They're just all over the place. So it's 1 million milligrams to centigrams. Is that right?
Yeah.
Okay. All right. So you may have seen this in class.
Not this particular one, but similar.
You've seen that in the past. Okay. So 1 million milligrams. So milligrams is going to go on the bottom and centigrams goes on top. And I think the challenge is like, well, which one is it? Like it's whichever you need more of to get the other. So like 10 milligrams are in 1 centigram, because you need more of these to get one of those. And it works the entire way. Like you need 1,000 meters to get 1 kilometer. So that cancels with that. The 10, you just cancel one of the zeros. So you end up getting 100,000 centigrams.
That's
Okay.
straight.
Yep. 16 here. I'm gonna have to just write it because it's not snipping in very cleanly. It's 1 million micrograms, and you're going to grams. Okay, so you start with your micrograms, and you know how many micrograms are in a gram or how many grams are in a microgram. So there's 10 to the 6th micrograms in 1 gram, I believe. And your teacher should be providing some conversions for you. Looking for it. Maybe not. Kind of there. I don't know. Not really. So you're gonna have to know some of these.
Yeah.
And this is just one of them. So this is also 10 to the 6th up here. So this ends up being, they just cancel out. It's 1 gram.
Wait, there's a million micrograms in a milligram or in a gram?
In a gram, yeah.
That's insane. So what? Okay,
Well, it
so
gets even, I mean, there's even smaller. There's picograms. I mean, there's femtograms. I don't know. There's all these other ones. Okay. 20
number 18.
or 18, 1 million centimeters to meters.
That's correct.
1 million centimeters. So we need to figure out how many centimeters are in a meter or how many meters in a centimeter. There are 100 centimeters in 1 meter. 2 of those zeros cancel with 2 of those zeros. So you get 10,000 meters.
100 centimeters.
10,000. Are you seeing my screen?
Yeah, I'm seeing it.
Okay. Just making sure, because sometimes it doesn't always. Okay, 2020. 20 is 1 million micrometers to centimeters.
Let me look. 20 all the way up. Yeah, 1 million micrometers in centimeters.
Yeah, so here, this is actually a good one to do, because you like, if you have your table here, you can actually go directly to them, but I actually always prefer going to that base unit. So there are 10 to the 6 micrometers in 1 meter, and then we go meters to centimeters. That way you don't miss a power of 10 or something. Like, you always go to the base one if you can, back to it. So there are 100 centimeters in 1 meter.
Yeah.
So these cancel, meters cancel, and you're left with just 100 centimeters.
Oh, okay. Well, let me copy it. All right, on number 22.
22. So this one is 1 million centimeters to kilometers. It is 1 million centimeters. Okay. So and then that's
Kilometers.
to kilometers. Okay. So the problem here is again, like, you can go directly, but I like to go to that base unit. And if it's not clear what I mean by base, like it's meters, grams, seconds, it's that like one right in the middle. So there are 100 centimeters in 1 meter. Then I know how many meters are in a kilometer. There are 1,000 meters in 1 kilometer. So I try to just remember the ones that are easy to remember and not try to be like, how many centimeters in a kilometer? You could just easily get those off. So this is this gets rid of 2 of the zeros, this 100. This 1,000 gets rid of 1, 2, 3 more of the zeros. So you're left with 10. So it's 10 kilometers.
All right, on number 24.
24. Okay, so 24 is 1 million grams. 24 is 1 million. I don't know why your instructor's doing a million each time. 1 million grams to milligrams. So how many grams are in a milligram, or how many milligrams are in a gram? There are 1,000 milligrams in 1 gram. because there's the milligrams smaller, so you need more of it to get one of these. So that cancels, and that just 1,000 gives you another set of zeros. So that's from the original. This 1,000 gives you another set of zeros there, milligrams.
Well, let me write it all down.
Okay, up to 24, or do we have to go past that?
That's it for this part. Next is the worksheet that I sent you on Google Mail.
Okay, there you go. I see copy of chapter 1.
Yeah.
Okay, can open it.
Fine.
Some sort of pictures instead of whatever. So all of these questions,
No, 5 through 9.
5 through 9. Okay. I see steps for solving literal equations. Am I missing something? These seem like objectives. They don't seem like questions.
Oh, I might have the wrong thing then. My bad.
No problem. I'll just stand by here and you can let me know when you get the right one. It's not like more of these significant figures, is it?
I don't think so.
Okay.
I think I found it.
Great.
We'll be doing 5 through 9 for these ones.
Oh, so you got it off to me already?
I'm sending it out.
Okay. All right. Sorry. I
You
was
know,
waiting for it and I didn't know it'd come in. I was like,
It's very slow. It would go a lot faster if it did what I wanted it to. There you go. It should have sent that by now.
This Zoom thing's always in the wrong place. All right. There it is. Another copy. There it is. All right, so let's see here. We're talking about the Handbook of Chemistry. Is that what you'd like to start that question there? Okay.
Yeah.
All right, so there's a formula for percent error. Okay, so percent error formula here, which is what they're asking for. And I believe it's the absolute value of the, well, actually, let me check here. But I don't, there it is. They do have it in there. So the, they call it the experimental minus the true. Your book uses, or you got a little bit different language. This is accepted. I like the word true over the true, and it is an absolute value, so it's always a positive number for that.
Okay.
Okay, so here the experimental value is 0.7925. That's this number. And then the true value is 0.7988. Absolute value of that over 0.7988. So when you do this in your calculator, make sure you do the top part first. You can change the sign if it's negative, or you can just always make it positive. All right, do you have a calculator handy, or do you want me to do this?
I don't have a calculator handy at the moment.
Okay, 0.7925 minus 0.7988 all over 0.7988. Okay, so the answer here is 0.00789. I'll do it that way. Now, because it's a percentage, you need to multiply this number by 100. So you get 0.789%.
And I think my teacher said that he wanted us to round it up. So I think it'll be 0.79 here.
Okay.
All right. On to number 6.
All right, an object has a mass of 35 grams. Okay, so let me snip this in. All right, object's a mass of 35 grams. So they're telling you that that's the true value. On Anthony's balance, it weighs that amount. That's the experimental value. So experimental or observed value. Okay, so the percent error here is the experimental value, 34.85 minus 35 absolute value over 35. So the second number always comes twice. Okay. So here you get 0.0043. And then when you multiply by 100, you get 0.43%.
On to number 7.
Number 7. Okay, so again here, this is same type of problem. The teacher told her that it should have been. So that's whatever it should have been. That's the true value. This is the observed value. So she's pretty high off here. So it's 54.5 minus 37.2 over 37.2. So she's way off here. The numbers should be fairly low if you do the experiment well. That's the whole point of this, is like, if you do it right, your percent error should be small. And what we're going to see here is that this is going to be quite high. It's going to be like 50%. So this is 0.4647. Sorry, 0.47. So then when you multiply by 100, you get 47%, which is too large, but that's what it is.
Pretty big mistake. Number 8.
Number 8. We get that snipped in. All right, Walter's planning a hiking trip and you estimate the gradient of the trail to be 213.6. That's the like observed experimental value. After hiking and tracking the trail, he found that the trail was actually 202.7. So this is the true value. So you just have to read the language to figure out which one's which. So we have 213.6 minus 202.7. What you can't do is like, oh, it's always the smaller number, or it's always the larger number. You actually don't know. So you have to be really careful there that you don't make that mistake here. So just entering this into the calculator. So that is 0.054. And then we can multiply by 100. Always forget that last step. Always do that last step, 5.4%. So did he overestimate or underestimate the gradient? So it
Okay.
depends on, well, it's not because of that, it's because of this number right here. This means that he overdid it because it's larger. Because this is always positive. Excuse me. All right. 9. To win in a qualifying round in a duck race, a duck's rate of change needs to be, okay, so they're telling you, they're saying this is what it needs to be. This is the true value. Kate was training her duck at a rate of change of, so this is the like observed value. So the percent error is the observed, which is 33.9 minus the true 35.4 absolute value over 35.4. So you can see here that the estimate, it was an underestimate because it's too small. But again, when you use the absolute value, you always get a positive number. Okay, so that's 0.042. And then you multiply by 100, and that's 4.2%.
Awesome. That's the end of those physics.
Great. Great.
I'm going to send you some math problems. All right, I just replied to the email with the attachment.
Okay, I'll take a look here. Let's see, waiting. There it is. All right, so we got another set of word problems this time. Okay, these are always fun-ish in quotes. So where do you want to start here?
Number 7 through 12 on group 11.
7 through 12. Okay. All right. So the first one is the train problem here on the left that I'm seeing. I don't know why these train problems are so universally used. Okay. Train made a trip at uniform speed. Had the rate been 5 miles per hour faster, the trip would have taken 24 minutes less time, but had the rate been 4 miles per hour less, the trip would have taken 24 minutes longer. Find the distance and rate. So there's two scenarios here. There's trip one. Trip one has a distance d. It has a rate, okay, and it has a time. What is the rate here? The rate is 5 miles per hour faster.
Yeah, so R
That's,
plus 5 and R minus 4.
yeah, that's going to be in our second equation here. And the time, though, if it was plus 5 is t plus 24. Now you got to be careful here because it's in minutes, which is a little bit weird. I'm sorry, 24 less time, so t minus 24. And then this one is t.
So we did like part of this problem like in class, but we didn't really get the answer. But I do know that she set it up as t minus 2/5 because it's 2/5 because 24 is 24 minutes is 2/5 of an hour.
Right. So that's one of the issues here is you do have to do that. And that's fine. I mean, that's just part of the deal here. So t minus 2/5, t plus 2/5. Okay. And the distances are the same. They're the same. Okay, but we're missing something here. We're like missing another equation. Oh, so there's another one. Distance equals rate times time. There it is. Okay. That's sentence one. Sentence one is that one there. Okay.
Okay.
So you can set these equal to each other. And I'm sorry, these two equations, and you can, I guess you can, man, this is messy. Why does your instructor do this?
Yeah, these are really annoying problems.
Yeah. And you're not allowed to use a calculator, or you are?
No. You won't.
Yeah, so this is pretty tough here because I mean, you have three equations, you just don't have them in any nice form here. I guess you set these equal, so you have r plus 5, t minus 2/5 equals r minus 4, t plus 2/5. And then I guess you pick one of these and you put it up in this other one. Yes. Ah, boy, r plus 5, t minus 2/5 equals r times t. And then ratio of these is 1. So if you divide these, that ratio is 1. I guess I don't know how you don't resume to a guess and check approach. Like you have enough equations here because you have it all here. But it doesn't work. It doesn't work like that. All right, let me I guess try foiling this. So that's RT minus 2/5 R plus 5t minus 2. So I guess you can solve that for R T. Guess. Oh man. Oh my goodness. Yeah, I mean, there is no elegant way to do this. So minus 2/5 R, I'm sorry, plus 2/5 R minus 4t minus 8/5. Okay, and then if you, okay, so that is what's needed. So then you take this and you put it in for D and then for D, and that becomes the right-hand side here. So I'm gonna go a little bit off screen here. So this D is here, okay, and then it becomes RT equals RT minus 2/5 R plus 5T minus 2. RT equals RT plus 2/5 R minus 4T minus 8/5. Okay. And these cancel. So you have your top equation now, 0 equals minus 2/5 R plus 5T minus 2. Your bottom equation is 2/5 R minus 4T minus 8/5. Okay. And this is kind of like an advanced technique. You just add them together because these are going to cancel. So you get 0 equals T minus 2 minus 8/5.
Okay.
And then you move like this right here is minus 10/5 minus 8/5. So it's minus 18/5, and you move it over. So T equals 18/5. Okay, that's in hours. That's in hours. So if you multiply 18/5 times 60, you get your answer here, because that's 12 times 18. So whatever 12 times 18 is. Yeah, 216 hours. Wow, it's a long time. No, minutes. That's minutes. I'm sorry. That's 216 minutes. Okay. Sorry for that. So now we've got the time. Now we need the rate. So you go back to one of these problems where I give you the time, and then you can solve for the rate.
All right.
So let's use this equation here. Somehow that fits my eye better. Put it back over here. So the time is 18/5. So 0 equals 2/5 R minus 4 times 18/5 minus 8/5. So we have 0 equals 2/5 R minus 72/5 minus 8/5. So that becomes minus 80/5 or minus 16. 0 equals 2/5 R minus 16. Move the 16 over, 2/5 R, and then you multiply both sides by 5/2. Okay, 5/2, half of that's 8, so it becomes 40. Your rate is 40 miles per hour. Everything I did here after this step up here is just horrible algebra, like just horrible. So if you're not fast at this, like this is going to really make this hard because you got to get really fast.
Yeah, I'm not very good at this.
Yeah. And I don't mean to be the bearer of bad news, but that is what you're up against here. Like you really have to know your stuff. I don't know. I don't know how other people are doing in your class. Maybe just form a study group and try to get faster. I don't know. Okay, so you said number 8.
Yeah, that's right.
Number 8. This one is slightly easier. The mixture nut problems or mixture problems are once you understand the form, they're kind of straightforward. All right. So dealer has two kinds of tea. I'm sorry, tea. This is a tea problem worth $1 and $1.20 a pound. They want to make a mixture that's 120 pounds. So let's just say X is the $1 type and Y is the $1.20 type. There's usually a total weight equation, and that's X plus Y equals 120. Okay, so like the total pounds together is 120.
Right.
Now, just looking at this, it's going to be more of the $1 type to get it closer to 1.04. So you have $1 times X plus 1.2 times Y equals 1.04. times x plus y. But what is x plus y? It's 120. You follow that?
Yeah, I do.
Okay, so this is x plus 1.2y equals 1.04 times 120. And then you just figure out, which one of these you want to solve for up here. So y is equal to 120 minus x, and we're going to use that. We're going to use that down here. So it'll be x plus 1.2 times 120 minus x equals 1.04 times 120. So this is x plus, and then 1.2 times 120. You're not allowed to use a calculator. Is that really right?
Yeah, that's correct.
Okay, well, that's a separate skill, but we're not going to deal with that right now. And then 1.04 times 120 is 124.8. Okay, so then you combine like terms, and that gives you minus 0.2x, which looks bad, but when you subtract 144 from both sides, okay, you end up getting a negative number over here. You get minus 19.2. You divide both sides by minus 0.2, and x equals, what does it equal, times 10? It equals 80, I'm sorry, 96. 96. Okay, so that we're not done though. That's just the first part. That's just x, but we know that x plus y equals 120. So that means that y must equal 24 pounds. Okay, so what's the game plan here for the second hour? Are you wanting to go through just these problems? Do you have more than this? What's kind of your game plan?
These problems.
Okay, well, there's no reason to rush here, so let's take a break. And how many do we need to go through?
9, 10, 11, 12. So 4 more.
Okay, yeah, well, that should be fine. Okay, let's take about a 10-minute break, and I'll see you back at 9 o'clock.
Thank you. Bye-bye.
Thank you. See you shortly. Bye.